Good morning. Thanks for joining us for our last virtual job spotlight of the year. And we are again on architecture and construction. My name is Lynn April. I'm with CESA 8, and along with me is Allison Bowie from NWTC. And those two organizations, along with CESA 7, the Ahnapee Youth Apprenticeship Consortium, UWGB, and Inspire Northeast Wisconsin, are hosting these virtual job spotlights this year. So we have three guests today. We have been looking at architecture and construction on the career side of things. So today we're going to be looking at post-secondary education. So we have Tom Herbert, who is with NWTC, the gas utility and construction instructor. We've got Tom Felton, who is NWTC's architectural technologies instructor, and Tom Lanovich, who is NWTC's civil engineering technology instructor. Just a reminder of our meeting norms. Our meeting is being recorded and will be rebroadcast through Inspire Northeast Wisconsin. Everyone is muted and their video capabilities are turned off just to minimize distractions. You will see the presenter slides on my screen, so just be watching for those. If we have folks leave the meeting, you may not be able to get back in, but I will be watching that as we go along. But we do ask anyone who is joining us live to ask any questions you might have through the chat. So if you have any questions for any of our presenters, we have some Q&A time after each presentation. So please do type that into the chat. And we never anticipate needing to do this, but we do have the ability to remove anyone from the meeting if they're becoming distracting. So we have our first speaker is Tom Herbert, the NWTC gas utility and construction instructor, and we're going to go to his slide. So Tom.
Good morning, everyone. Tom Herbert from NWTC. I teach the weekend gas utility program. And just a little introduction for myself. Grew up in Wisconsin, went into the utility industry in my mid-20s, and the utility industry provided an opportunity for me to travel really around the United States. Spent some time living in Indiana for about 10 years total, 2 different times. Lived in Boston for about 5 years. Traveled to, I would say, at least 25, 26 states across the United States, really with gas and electric utilities. And what I'm here to talk with everybody about today is just some of the opportunities that the program has provided me, but also the opportunities that the program potentially could provide you. So if we could go to the next slide. This is when you look at the natural gas industry, it's broken down into 2 segments. And on the top of the screen, you can see producing wells and gathering lines, compressor stations. That is the transmission side of the business, larger pipe and higher pressures. And when I say larger pipe, I'm talking 48-inch diameter pipe and maybe 1,000 to 2,000 pounds of pressure that is being produced in those pipes to get that gas to Wisconsin. A majority of the gas that we burn in Wisconsin is coming to us from Colorado. So it's coming a tremendous amount of miles to get to us. Where we focus the training on at NWTC is going to start us at the City Gate Station. That's kind of in the center of that picture there, where Wisconsin Public Service or whoever your energy provider is going to take ownership of that gas from a transmission company. We're going to pump that gas down to about 60 pounds, and then we put it into all the lines that are going to be underground and going to your homes, businesses, whoever is going to be burning that product throughout the cities and in the rural areas also. We can go ahead to the next slide. So what I want to talk about is a couple of the pieces of equipment. And I think one of the misconceptions too, when you look at some of the equipment that you have on the screen, like a lot of this stuff is very serious, right? Can hurt people, can get a lot of work done. But you do not need any experience level to come into these programs and be productive and gain employment. There are many times that we get folks coming in, that haven't started the lawnmower, and we have them operating plenty of heavy equipment in a very safe and effective way. So the top picture, if you look at that machine, that's a directional drill unit, and we bring people in, and literally probably your second day, you're operating heavy equipment like this. And the directional drill, if you look out in the industry right now, is one of those pieces of equipment that when these graduates come out, they're probably somewhere in that $35 to $45 an hour range operating that piece of equipment. The next piece of equipment on the top right is a mini excavator that is used on a daily basis for the industry. It's versatile, it's small, it's compact, you can get into yards, but that piece of equipment also, just like the directional drill, we train you on that. I mean, we start really at the infancy of how the machine works, from a distance, how to change the oil, how to maintain it, how to check fluids, and just basic types of things. And then we get you on this piece of equipment, and our program runs 9 months. But in that time, almost daily, you'll be on that piece of equipment because it is such a part of the utility that we incorporate it into almost every learning plan that we have. So on the bottom right, you see a backhoe, another piece of equipment that's versatile in the utility that, again, you don't have to have experience on. And I do hear this often that, hey, I don't really know how to do this, or I wasn't sure if this was something for me because I didn't know how to operate that. That is actually a preference of myself for sure as an instructor, to have somebody come in with no experience and get them to the level that they're comfortable and confident and employable the day after graduation, if not before. So the bottom picture in the middle looks like a coil, and it's a coil of pipe. A majority of the pipe that we put in the ground now, actually probably 99% of it, is plastic pipe. And it comes in rolls like that. It comes in rolls about 960 feet, and we unroll it. We dig a trench, put the pipe in the ground, bury it back up, put natural gas through it, and get it to a customer. We're not sending rockets to the moon here. However, the jobs that we perform are deemed essential. By the government, by the federal government. There's a lot of rules and regulations that we follow. So the jobs are taken seriously. And that's why when I look at the class that I had this year, I had 16 students, and those 16 kids were employed prior to graduation. And I think my lowest paid student was, 26, 22 an hour. And that went all the way to 40 some dollars an hour. And the other thing that I love about this program is I went through the program back in 2005 and graduated, and was able to, I had 4 job offers prior to graduation, and I ended up moving to Indiana to be a technical trainer for a Fortune 500 company named NiSource. They were in 15 states. It was a huge company, and it was a great opportunity for me. And the program, being that 9 months, starting in June and then ending in March, it is fit perfectly for the utility industry. And for those kids that really like to work with their hands. And typically we're getting, kids that are really like shop classes, but that doesn't mean a valedictorian or somebody that's, highly educated couldn't come into this career and be very, very successful, because there are so many different jobs in a utility. You want to be a mechanic, you want to be a welder, you want to work in the dirt, you want to be an operator, you want to be a manager, you want to be a vice president. There are all sorts of opportunities that can stem from these careers here. So the last picture on the bottom left there is a gas meter. Most folks don't know if they have gas coming to their homes or not. If you walk around your home and this type of a meter is on your house, you have natural gas coming to your home. And that's just something that you can identify to be a little bit more knowledgeable. You can go to the next slide. Now, one of the great things about our program also, and this is all over the country, is we have so much outdoor space that we can do outdoor learning, because working in the natural gas industry is not really something you can read out of a book or do a computer module on. The gas industry is something that you have to get your hands on. You have to understand how gas works and how pressure works. And, actually being in the dirt when it's warm, when it's cold, when it's raining, when it's snowing. So NWTC has really set those students up and instructors up to be hyper successful by having all of this opportunity with room and growth for expansion. Now, when we look at that picture, right, it's a picture and we see roads and dirt. The gas utility section is really the spot where you can see kind of the dirt in the ground, and you don't see grass. And then up in that wooded area, so we have a tremendous amount of room that everything is lifelike and people aren't tripping over each other in the lab. We can space people out, keep everybody safe. Go ahead, next slide. So one great thing about our program is it's been around since 1988. And the great thing about that is longevity, especially in a program, means success. And we've had a lot of really good success with the program, and even in the last couple of years. I've only been back at the school now for about 2 years, 2.5 years, teaching the weekend program. But we've built a really good roster of companies that every January, February, we have a career fair where companies that know and understand what we're producing, the product being the student, that they're coming in and hiring these folks. And the great thing that we had this year is COVID did exactly the opposite for the gas industry of what it did the most. It did not slow us down at all. It actually picked up our speed to do replacement projects, put more pipe in the ground to get it to our product to more customers. So the fact that with my students coming out, all these kids having jobs just speaks to the amount of time and effort the college puts into those students, but also how believable the industry is in us, in our ability to train folks to be in the industry and be productive day one. So something we look at this third bullet point here, something that I want to draw your attention to, whether you take the gas utility program or not, and I tell my kids the same thing. There's a couple things you want to focus on, and you see 96 and 89% there. You want to ask a program, right? What's your graduate to employment rate, right? And we see that ours is 96%. So that means most of the folks that are coming into this program can graduate, right? It's not overly difficult where everybody's failing. It's not overly easy where everybody's passing, but that 96% is pretty high. The second number being 89% employed in the field. You don't want to go to school to be gas utility and then you're working at a dog track or something like that. You want to make sure that the degree you're going for, the education you're going for, is transferable into an industry that is going to be directly related with your education. So when we look at that 89% employed in the field, and these were last year's numbers, and our numbers will be even higher this year, those are pretty critical. And then our average starting salary for a lot of these kids coming out is right around $60,000 a year. But when I think of the kids that I had last year, a lot of these kids will make $100,000 literally their first or second year, and then that'll be a continuation, from this point forward. But I will say this: if the only thing that I'm saying today that interests you is money, do not waste your time or the school's time, because the money isn't everything, right? You want to have a career that you enjoy going to every single day, not just where you're going to make a decent amount of money. You can go to the next slide. So just a quick overview. When we look at our curriculum, there's 33 credits in that 9-month technical diploma. Again, we're running from June and we're ending in March, and not a ton of difficult classes in there. But what I would say is look at that curriculum there, if you can see that. And if there are things that you can take in high school yet to kind of knock those things out, and I think about College 101, the communicating classes, please do that, because when you come to college, then you'll be much more prepared to just be able to focus on the core classes and what you're getting an education on, and really the career. And then kind of lastly, what I'll leave you with is a couple things. The hands-on portion of this, probably 90% of our program is hands-on. And I mean, there's very little lecture in that. Our lecture even is outdoors, but we do a lot of shop time, both inside and outside. So for anybody that is willing to do, to put in that work and be utility ready, the day after graduation, I would welcome you to come in and check the program out. And something that we do for the weekend program, that Friday, Saturday, is we bring folks in too that want to shadow, because I think it's just important to know what you don't want to do as it is to know what you do want to do. So we give outside folks, non-students, an opportunity to come in and sit with the class. And we're typically there for 9 hours. You don't have to stay that whole time. But when we go to the last slide, I would just say there's my contact information. If you do make contact, just let me know who you are, that you were part of this presentation, and I would welcome you to come in. Now, we don't start back up again until June 6th. So we are out of the area, we're not at campus. But anytime really from June until March, if you can make it in, I would strongly suggest you do that to see if the gas utility program would be a great fit for you. That's all I have.
Is it there a possibility that like a tech ed class could come in during school next year while the class is going on and kind of see what happens in the course?
Yeah, absolutely. And I would say this year, the recruitment that I have been on with schools, and I've probably been to 30 different schools, either in person or virtually. I always make that offer, and we do get, students that'll take us up on that. And I always tell them too, if you're nervous to come, bring a parent, bring a friend. You don't have to come alone, because I get you're coming to an unfamiliar place, and we'll try to make you as comfortable as we possibly can in our environment. And what I typically do with those students that come in is I put them with other students, right? They don't want to listen to me talk all day long. They want to get involved with, right? They want to get involved with the students and see really what it's taking to be productive. But again, for me, the program was so fantastic, and it's still fantastic, right? Working back at NWTC again is kind of coming full circle for me, and I love it. I like being with the students and trying to take what I learned in 16 years through being a trainer, a field operations leader, and then an operations manager, and trying to give that experience to those kids in 9 months. There's a reason why those kids are leaving with positions in that like 7-8 month period rather than having to wait till graduation.
Allison, do you have any questions?
There are no questions in the chat. I just wanted to make a comment. I've had the privilege to be able to be in Tom's class, and I do highly encourage any student or faculty, teacher, whomever, to take Tom up on the offer. And it's maybe even more so for highlighting the importance of a program that you just don't think about. You don't think about how you get hot water. You don't think about how the heat comes to your house, but how important it is, and how the need to be safe in it, and feeling like you're part of a bigger solution, I think is an appealing draw for this particular program. So that is what I'm going to say.
And these jobs exist in every state. I mean, right now, I'd be willing to guess there are probably 1,500 jobs, available jobs out there for students right now. So it's fantastic. But
All right.
Thank you.
Thank you. And we will transition to our next instructor, Tom Felton, who is with Architectural Technologies at NWTC. So Tom.
All right. Yes. So I am Tom Felton. I am the architectural technology instructor, not the actor that plays Draco Malfoy in the Harry Potter movies, just to make that clear. So when I was in high school, I thought I wanted to be an architect and was told that I needed a 4-year degree to do that. So to help pay for college, I thought it would be a good idea to join the Army Reserves to make a little extra money and take advantage of the GI Bill, which was fantastic. And I did start my schooling at the Milwaukee School of Engineering. So I went there for the architectural engineering program there for 1 year. And after that first year, my reserve unit got called up to active duty in support of Operation Desert Storm. So I did not go back to school at MSOE. I went to Saudi Arabia instead and spent about 7.5 months there in support of Operation Desert Storm. Now, when I returned, instead of going back to MSOE, I decided to go to NWTC instead for the Architectural Technology Associate Degree program. And what I discovered was that with a 2-year associate's degree in the state of Wisconsin, I could still actually become a registered architect if that's something that I wanted to do. So 2-year associate degree, a certain number of years of experience working under a licensed architect. I think it's about 6 now. And you can actually still sit for the architectural exams and become a registered architect. So there is a path to do that without getting a 4-year or master's degree in architecture. The one thing about it though is that you can only practice architecture in the state of Wisconsin. Now, that doesn't mean you can't design things in other states as well, but you can't stamp those drawings officially. As far as designing with your associate's degree, you can design houses and other residential buildings with that degree. So you don't have to be a licensed architect to design a house. After my associate's degree, I actually moved to Seattle, Washington, and worked for a company there, an architecture firm, MG2 Architecture. And the projects that we did was all commercial buildings and a lot of Costco stores and retail, other retail type buildings, the occasional office building here and there as well. So I worked my way up to become the CAD manager at MG2 and decided to move back to Wisconsin. I came back and started my own business named QualCAD. So I ran my own outsourced drafting company, and that was fantastic. Actually gave me a little bit of spare time, and that's when I started teaching part-time at NWTC in the architectural program. I found out that I really liked teaching and ended up going through UW Stout for my bachelor's degree in adult education. Upon completing that, I started an architectural technology program at Western Technical College in La Crosse. They didn't have one. I actually developed it and taught there for 3 years. At that time, it was time to come back to Green Bay. Came back full-time teaching at Green Bay since 2008. And I also went back to UW Stout once again for my master's degree in adult education. So my career path has been here, there, and everywhere. And when I started out, I had no idea that I was going to end up where I am today. All right. So our program, we do start out with residential design. So learning some of the basics of print reading and understanding what it takes to design a home, code requirements, as well as structural requirements. We focus on drafting two-dimensional plans and details. We also do some modeling, so three-dimensional modeling of our buildings, our residential buildings and structures. So we get into the structural side of things as well as the framing and all of that. You'll see some chicken scratching on the right-hand side of the slide there. And that's actually structural analysis. So we do some physics when it comes to the buildings and analyzing different parts of the building mathematically. We also use spreadsheets for estimating. So essentially counting the pieces and parts, what it actually would take to order materials to build the building. All right, next slide. Then we also get into commercial construction, and we get to have a little bit of fun designing buildings and documenting that building details. So we do some renderings, some 3D modeling and renderings and presentations regarding those designs. But then we also have to get into the kind of the technical side of it. What does it really take to put on paper to be able to build the building? So we document it from the inside out, including the structural elements. So the steel connections, concrete and reinforcing. So we look at all aspects of the building. Okay, next slide. And the one thing that is probably the most exciting in our field right now is BIM, or Building Information Modeling. So more and more companies are embracing the technology and using it to their advantage for coordination. So we do have classes where we will model plumbing systems, ductwork for mechanical systems, as well as electrical systems. So building all those things into the model helps you to determine where there might be some clashes or issues before actually getting into the field. The center picture on this slide is showing something kind of cool. It's a three-dimensional scan of an existing building. So they take a 3D scanner out on site, they scan the existing building, bring that model into their design model and manipulate it for doing a remodel or changing equipment or adding machines or other things to that building. And then the last picture on the slide is showing a mixed reality view. So what we can do is actually, when the building is being built, while it's under construction, put on virtual headset or have a tablet or something out in the field, walk through the building and see where the systems are supposed to go. And we can actually see that those modeled components in the real space virtually. So it's kind of a cool thing. The direction that the industry is going is modeling everything and being as precise as possible before they actually start building the building. Okay, next slide. As far as preparation in high school, focus on math, that's important. So algebra, trigonometry for sure. If you have an opportunity to take some physics classes or a physics class would also be helpful as well. Now in our program, we do use various software, primarily Microsoft Office products for word processing, spreadsheets, presentations. If you have other experience with those types of things, that would be helpful. And then for the two-dimensional drafting, we use AutoCAD. So there is still a need to do 2D drawings and manipulate AutoCAD. And then our 3D modeling software is Revit. And that's primarily what we use for, that's our architectural modeling, our structural, all of the systems we do in Revit. So if you have an opportunity to take, either of those two classes or really any drafting type courses, whether it's software or, hand drafting, sketching, that's all helpful for sure. I know that Tom mentioned about, shadowing classes and things, and we're certainly open to that. We will be in person in the fall, so there are opportunities to do that. We also have some students do what they call, I think it's Start College Now, and they actually take some college classes at NWTC as part of their high school courses. So that's also an option. And, we're open to have high school students take our courses and start early. So that would be fantastic.
So when we were talking the other day, and you mentioned previously that you don't have to have that bachelor's degree to be doing architecture, that you can actually be doing the drafting with an associate degree. But we also talked about certification. So can you talk a little bit about that certification and what that allows you to do?
Right. So, becoming a licensed architect is essentially designing commercial buildings or multifamily apartment buildings, condos, those sorts of things. So having that registration allows you to do that. Again, you can get that registration through a 2-year degree, but again, you can only practice in the state of Wisconsin. With a 4-year degree, you can practice anywhere essentially in the country. Now, as far as designing homes, there is no need to be licensed or certified in any way. So walk out the door with your associate's degree, you can design homes. Assuming they meet code criteria, you're good to go. There are other areas that you can become essentially licensed in. We've had graduates go on to become licensed plumbing designers, or even in HVAC and the mechanical side of things, you can, with experience, take the exams and become an engineer in specific to those areas.
Even though you don't need to have certification, for example, to design houses, if you were to seek employment with, you know, an architecture firm that does build houses, are they more likely to hire somebody who has that certification?
No.
Okay, good to
Plain
know.
and simple. Nope. To be honest, most homes are designed by people with associate's degrees. If you go to the lumber yard and you buy all your lumber materials and you get the house design from the lumber yard, 99% of those people that are doing the design only have an associate's degree.
All right, that's great to know. Allison, do you have anything?
There's no questions in the chat. I recall companies coming in and talking with your classes and just how impressive some of the projects are that students jump right into. You know, the Lions Stadium, I remember a student talking about him working alongside that whole team. So eh, I just, I think that misconception of 4-year versus 2-year again, but just you jump right in because you have jumped in this program. So you're sitting right next to a whole team of engineers and you're just part of that team.
Right, absolutely. And what we're seeing is our graduates are becoming integral because they are the ones that are running the model. They're in control of the Revit, the software, and maybe the actual architect or engineer. They're not working on it every single day. So they bring in the technician to show off the model to the client. So they're becoming more integrated into that team for sure.
All right. Well, thank you for
Mhm.
all of that great information. And we will transition to our last speaker, Tim Tomlanovich, who is an instructor in civil engineering technology. And I'm going to stop sharing and go to the speaker view. There we go. So we can
Hello.
hear from Tim.
Hello, everybody. Good afternoon. So my name is Tim Tomlanovich. I am a professional registered civil engineer in the state of Wisconsin and the state of Michigan. I used to be registered in several other states. Civil engineering, when you look at it, it's actually is involved with gas utility architecture. We actually, it's kind of interesting when you look at the programs you just heard about today, is that, believe it or not, us civil engineers were involved in that. Like Tom said, and Tom, we're a integral team. So we're involved in more on the front end stuff, the design stuff. Civil engineer, our first president was a civil engineer. There's different branches of civil engineering: geotechnical, structure, transportation, water resources, environmental, and survey. I am a geotechnical engineer. So basically, my famous analogy is the Leaning Tower of Pisa. Is why is it leaning? Is because of the soil. So I engineer soil, and I engineer from the ground down, foundations, concrete. So my career path was, I got an associate degree in architectural design because I thought I wanted to be an architect because my family was in the construction business my whole life. And then I actually ended up working for a civil engineering firm doing CAD work, AutoCAD. Dating myself, it was one of the first versions of AutoCAD, doing drawings, and then they needed extra body to go on a drill rig and do construction observation. And that's when I really was watching like how they were taking soil samples and doing compaction and watching the construction process that really got me interested in civil engineering. I found out what civil engineering was, especially on the geotechnical side. Like how do we engineer? How do we make sure that building is staying up? How do we make sure that Leaning Tower of Pisa isn't leaning over? So 4 years of doing that, I actually went back to college at Michigan Technological University in Holt, Michigan. I got my bachelor's and master's degree in civil, and my master's was in geotechnical. I ended up going back to the same firm and got to work on you name any project all over North America, dams, transmission lines, commercial buildings, failures of dams. I was up in Canada working on the oil sands up there, because typically when you look at most projects, they start in the ground. So we're dealing with soil somehow, some way. We're supporting buildings on the earth, basically. So I did that for 15 years, worked with some amazing engineers. I love, teaching because I had some great teachers. I actually got to work with the engineers that designed and did the geotech for some of the tallest buildings in the world. So I feel really privileged about that. And then NWTC came. I got just got tired of traveling, and I wanted to raise my family. So here I am at NWTC. So that's kind of a little background about me. I love rocks. I love dirt. So, um, civil engineering technology is a very unique program. It's actually two programs in one. So I teach the civil engineering courses, and then there's actually a survey side of the world. So there's actually surveying, which is involved in everything. So surveying is actually using robotic GPS stations, locating things out in the field, locating the gas lines before Tom Hebert is actually installing them, architecture, all that. So there's the surveying side of the world, and they do AutoCAD and Civil 3D, and that's one career path. And then the second career path in the surveying is they call them a survey technician. Is when they're out in the field, they actually have to gather the survey data, gather it in a GPS data unit, and they actually bring it back to the office and they download it in the AutoCAD Civil 3D, and that's what makes the construction drawings and locating utilities, working with the architects and all the utilities. I mean, it's an integral part of all of this. So that's another career path. The person actually out in the field gathering that data. The third career path is the civil side. So I teach here at NWTC. I teach. It's called cemented aggregate mixtures. So when you look at concrete, is the most worldwide used construction material around the world. So when you look at concrete, there's three main ingredients. That is aggregate, water, and cement. Cement is the glue, basically, that's holding the aggregate that creates the strength. It's kind of like the backbone. It's kind of like the bones in your body. If we didn't have aggregate, cement's pretty weak. Our buildings would fall down. So we spend believe it or not, there's a great deal of engineering on the aggregates, especially local bedrock sources. I go all the way back to second grade science, three types of bedrock: igneous, metamorphic, and sedimentary. So basically they blast all that out of the ground, they crush it and make it the size, and we analyze the properties to make sure our concrete's gonna last for construction. And then the same thing with asphalt. So there's concrete roads, concrete buildings, and there's asphalt roads. There's two ingredients in asphalt: aggregate, and you got the bitumen or the asphalt. And the asphalt is the glue that holds the aggregate structure. Same kind of thing. We have to spend a great deal of time of engineering. And then the third thing that I teach is soil mechanics. So when you look at a construction site, if you ever been on when the 41 mega project, there was lots of earth being moved around, embankments being built, soil being moved around, and then we actually have to measure the in situ strength of those properties, and we have to make sure that that soil is properly placed and compacted so we don't get settlement, undesired settlement, and sinkholes or the leaning tower of Pisa. So there's a great deal of engineering the soil and engineering aggregate. So I also teach in the civil engineering technology program. I teach statics and strength of materials. That's very similar to what Tom in the architectural. We teach, they take physics and we understand how loads are transferred down into the soil. I actually teach Tom's students on the structural analysis side of the world. We also deal with water resources, water technology, stormwater, sanitary sewer, because typically our civil engineers, we're designing sanitary sewers, we're designing gas lines, we're designing stormwater ponds, we're out there surveying, gathering that data, and we actually have to size the pipes and locations. And and I also deal with construction methods and engineering inspection. So basically, our students, it's a very hands-on program. Basically, they're out in the field or in the lab or in the office doing AutoCAD. We're the eyes and ears of the registered professional engineers. So basically, our students are out there gathering that survey data. They're out there inspecting the construction. They're in the lab testing everything to make sure everything is installed according to how it was designed based on that plan set. So a lot of times our students are observing like students like Tom Hebert's, making sure they're actually installing it the way the plans and specs say they need to install it. So that's kind of a third career path. So that's a little bit about the program. We are also ABET accredited. So what that means, we're the only ABET accredited 2-year associate degree in the state of Wisconsin for civil engineering technology. What that means is to become a registered professional engineer or a registered professional land surveyor, you have to graduate from a accredited university. Either it's 4-year or 2-year. So because only Wisconsin, because we're a 2-year accredited program, our students can sit for the professional surveying license exam and a professional engineering exam with more education. Otherwise, similar to Tom, if they want to practice in another state, they'll have to get it. They can move on and get their bachelor's degree. So our students are 100% graduation rate, 100% in the field. Average salaries between $45,000 and $50,000 a year starting. They do an internship every week. My coworker Mark Kameen, he's a survey instructor. We seem to be getting emails, at least 2 or 3 from just employers in Green Bay looking for our students because they need those hands-on engineering technicians, they call them civil engineering technicians, to build infrastructure. So my last thing here is when you build infrastructure, we look at our infrastructure, it's getting older. We need to replace it. Civil engineering will never go away. Our cities are getting bigger, population is getting bigger, infrastructure is getting older. Civil engineers are involved from start to finish somehow, some way. So that's a little bit background on my program.
Very cool. That's a lot to take in, but great connection to infrastructure. We're hearing a lot of that right now in the political end of things because they're
Yes.
talking about what's infrastructure and what's not. I mean, how fascinating to know that has a direct connection to your program.
Absolutely.
I would not have even thought that.
Yes, and our students, they're all over the United States. They can they go across the world. So it's pretty amazing. It's a very valuable versatile program. If you love being outside and love that engineering mind, how things are constructed, this is it. So
I'm trying to come up with an intelligent question, and I don't even know what I don't know. But I was a farm girl, so I have made some concrete in my day.
Okay.
So when you are constructing, when you're using concrete for a building, for example, what do you estimate is like, obviously we would love that to last forever. What is in the program? How do you figure out like how many years is this concrete going to be structurally sound, for example?
Right. So typically a design life is 50 years.
Okay.
Is typically when we do our structural calculations and our concrete calculations. Um, it's 50 years. So yeah, when we're engineering our aggregate properties, there's aggregate properties like our local limestone, dolomite in the area. There's chert in there, which is very detrimental. It decays, and you see pop outs when you see that expands especially in our freeze thaw environment. So yeah, so when you have a lot of that, we're dealing with a lot of that now, like the dams on the Fox River. I was involved in that project. They were deteriorating because basically back in the 1900s, they dealt with what they had. There wasn't really engineering, so they basically blasted it and crushed it and made the dam. So now we're trying to figure out, okay, how much longer will that deteriorate, or that's why you saw them replace a lot of the sections of the dams out there. So yeah, it's 50 years to answer your question. Is typically a design life, roadways, for pavement thickness, that's how they call it a life cycle cost, and they have to determine, okay, this asphalt's done, we need to either tear it out and replace it or patch it, and it's all those decisions. So
Great. Allison, do you have anything?
I don't know how to ask this question. However, bear with me. So the ground in Arizona is different than the ground in Wisconsin. So do you teach to that? Do like I don't even know what to ask, but just
Yes.
thinking about the differences.
Yes, yes, absolutely. So I teach actually soils, there's different soils all over the world. So there's basically 4 different kinds of soils. You got sand, clay, gravel, and silt. There's 4 main ones, and there's a universal soil classification system. So yes, so like in Green Bay, we deal with a lot of clay. It gets sticky and wet when you're trying to dig a trench. I'm going to engineer that differently than in Arizona when it's all sand. So yes, we basically when we just did a soil boring up in the utility substation. Reason why we do a soil boring is we engineer what's in place. We determine what kind of soil that is, what kind of soil it is, and then from there we do in situ measurements of strength of the soil, and then we take it to a lab, and then we figure out, okay, what kind of foundation is it? Shallow? Is it deep? We give construction recommendations, especially in the gas utility. Okay, water's 2 feet below and they got to dig 6 feet. They don't. How do we deal with that? Clay was less permeable than sand. So, Tom, I'm Tom Herbert. I'm sure you've been in below the water table trying to install a gas line. That's geotechnical engineering. That's what we're there for. We're usually involved in that process to help that construction process go on, and that's what our students are doing. They're out there watching and observing that. So
That's fascinating.
who know, you could get paid to play in the sandbox. My mom said that you're never going to make any money playing in the sandbox. Did I prove her wrong?
Oh, great information. Thank you so much for sharing all of that. Yeah, it's for those of us who don't have a science background, it's kind of overwhelming, but really fun. So I'm going to go to gallery view here so we can see all of our speakers. And thank you once again for joining us today and sharing all this great information about architecture and construction at NWTC. We will have the video available for students and teachers to use with your contact information in. So if you've got questions and you want to find out more about NWTC and architecture and construction, these are the guys to go to. So thank you so much for your time today, gentlemen. And I am going to end the recording.